Okay, I think we're all set. Perfect. Welcome, everybody. Hope you have a great time at the Devoxx Ticino. I just went outside of the park during lunch. Such a beautiful landscapes, really beautiful city. I wouldn't mind living here, to be honest. So this talk is about the era of AAP. And actually, AAP stands for AI-Augmented Programming, but actually AAP in Dutch, which the language that I speak, stands for monkey. And the reason why I find that very matching is that basically large language models and these coding assistants, they are replacing Stack Overflow. We used, or at least, last year you went to Stack Overflow, copied the code where you found the responses, and you just copied it like a monkey, not thinking about what you were copying. A lot of junior developers do that, and then they introduce new bugs. Well, basically, we're doing the same with large language models. Right? It produces this beautiful code, you just copy and paste it without thinking because you trust it, it's going to be not hallucinating at all, and then it hits you in the face, of course. Right? But what I really want to talk about is how I am starting to use Java to use a full solution for coding assistants, but purely written in Java. The thing that really irritated me is that I had to learn Python 5 years ago to play with all these things, with the lightest, shiniest libraries. But this talk is really showing you that we can do this end-to-end completely in Java. And the excitement is there, and that's hopefully with this talk I want to actually get this over, or get this over with, that message. Before we do that, just a few terminologies and just a few introductory things. So first of all, there's two big providers that you can use. You have local providers and you have cloud providers, right? The local provider ones, the Swiss knife, which is very appropriate being in Switzerland, is Llama CPP. Llama CPP is really the basis, it's written in C++, and it's really the engine for all the local models that started building on top of that. So we have like LM Studio, Ollama, and Jan. Those are the three very well known, and they actually run on Windows, Linux, and Macintosh. So the one I'm using is Ollama, but if you want to really see and debug what's going on, then LM Studio is also a very interesting one because it shows the logs of all the communications and you can actually debug it. So that's already interesting. And then once you have an LLM provider selected, you need to select models. The three models that I'm playing with these days is the ones from Meta, Llama 3.1, 3.2, 3.3. Depending on your use case, you switch to one or the other. Like, for example, Llama 3.2 has a 1 billion version, so it's very small. So that's a really great one, for example, if you need to generate a title or something based on a description or do a quick summary, things like that. If you want to do a bit more like coding assistance, then the DeepSeek Coder just recently released a couple of weeks ago, version 3, is like, oh, but it's from China. So you have to watch out with that a bit as well. They host it, and it's a fraction of a cost of other cloud models. A fraction of the cost. It's actually competing with Anthropic's Claude 3.5 version, but it's like 10 times cheaper. Right? And they just recently, Ollama has just released a quantized version, 4-bit one, for Ollama running locally as well. Right? And then there's Qwen, which is also a very well-known one. So those are the options you want to use. Just out of interest, who's using Llama for Meta? Okay, well, maybe start. Who's using already a local model provider? Not that many. That's good. That's why you're here. So I will try to inform you as much as possible. So why would you first use a local model? There's multiple reasons, but a big reason is privacy. Be careful. If you use a cloud model, they will train their next version of their models based on the prompts that you're feeding. Right? There's like this anecdote, Geoffrey de Smet from Optapladder, he has a very special way of commenting his code. Well, of course, it's an open source project. It's now rebranded to Timefold. And his comments were actually reproduced when he was asking, hey, to a model like, hey, create me an Optapladder code. He actually saw his special comments in the generated code. So anything that's public is being indexed. But if you send and use a cloud model and you have like proprietary or intellectual property and you're sending that to that cloud provider, it's gone. It's going to be public, right? So be very, very, even if they say in the small print, we don't believe them. No, I'm not joking. So having a local model has a a few advantages. One, privacy, but also, hey, if I'm on a train or on a plane or sitting in the toilet and I don't have Wi-Fi, I can continue coding with my code assistants with local models, right? So it has advantages. So what I often do is actually I start with a local model, and then because I'm often working on open source projects, I will then switch to a cloud model and to another cloud model and let them review each other's responses. I'll show you that later on. So the cloud models, the story there, the opportunities or the options that you have are these four. So we have Anthropic. The one I use on a daily basis is Sonnet 3.5, or some call it 3.6 because they did an update of the model, but they didn't change the version number. 3.5 for coding is, it's really good. Okay, it costs a bit of money, but we're talking about a few dollars, seriously, right? So it's peanuts, to be honest, and I use it daily, right? They even have a plan where you pay $20 a month, and then you have like a web interface where you can actually insert and create projects and then have a chat web interface. The beauty is that you even have a mobile app from cloud, so you can continue chatting while you're sitting in the toilet over your project or wherever you are, because you have some bright idea you want to balance, like, hey, what do you think about this approach or that approach? And I'm using it as a sparring partner. It's like my new best friend. No, I'm not that pathetic, but it's definitely my assistant. Google is very interesting because they're the only one who have a window context of 2 million tokens. I said that this morning in the keynote. And there's this Minimax now, which has 4 million, but that's just announced yesterday. And I am pretty proud as well that at least we have one European company from France, which is Mistral, right? So, but they're based in San Francisco, of course, for the VC money. And then we still have Amazon as well, and I know IBM has some as well, but I think those are, Amazon I haven't played with, but they've just released their own models called Nova, Micro, Light, Pro, and Premiere. Premiere is not yet released. So those are your options. Yeah? What's really cool, you can just get an API key, and then use that API key in a coding assistant, and off you go. And then you pay by the token. You need to balance it. Is it more interesting for you to just pay a flat fee per month, but then it's capped, or you just pay per tokens? So I actually do both. I start with my $20 a month. I'm cheap. And then if it's capped, I'll just continue with the open API, with the API key. I mean, come on. That's like $30 a month. You know, if I would have a senior consultant helping me, it's going to cost me €1,000 a day. And that's already where the dynamics changes. Okay, some other thing you need to know. So a chat or a typical large language model chat has a few portions. The first part is the system prompt. This is where you set the scene. This is where you say, for example, hey, you're an expert Java developer, right? And by doing that, the neural network will like focus in that area where Java has, you know, some similarities and so on. So that's very important. The system prompt is really important to set right. And this can be very long, right? It doesn't have to be just one sentence. And then the user prompt, this is where you send your chat, that's your prompt. And in the prompt, I think the previous talk did like prompt stuffing. I've never heard about that approach, but it really is like that. You add additional context to the user prompt. So the additional context could be your full project, right? And then you ask questions next with that context to get a response. Now, you can repeat this, and then it basically turns into a conversation, right? So the system prompt is done once, and then the conversation has a chat or a request response, and that's like your chat memory. So by doing that, it allows you to actually say like, hey, who is James Gosling? And then in the next question you say, how old is he? And because the previous question was already in the memory, it will know that you're talking about James Gosling, right? So that's like the conversation approach. And if you then ask that question to your models, that's called inference. You can do this on the local ones and in the cloud ones. And the beauty is that a lot of people don't know this, but you can mix and match this. You can really start mingling it and get the best of both worlds. Cool. So that was the introduction. Any questions? Am I speaking too fast? Is it okay? Because I get excited about this stuff and I go faster and faster.
Question about the different models. Maybe you already replied, you work a lot with cloud, but did you notice any difference specific for coding? I mean, there are some models, I mean, probably ChatGPT is the larger one, but maybe it's not that good at code, or can you suggest some other models that work better with code?
I mean, I'm laser focused for coding models, which are good at coding, right? But there are others where if you're like a creative writer, there are better models for being creative because their data set is really focused on, for example, ebooks and things like that. So there are models which have certain flavors, definitely, right? But I don't know those. Like I said, I'm focused on the coding ones. And Sonnet for me is, for the moment, the best one. The only problem is that it only has a window context of 200,000 tokens, so you're a bit limited. So if you want to go beyond 200,000, then I often switch to Gemini version 2.0, experimental version. And the experimental version, this is a secret, it's still free. So Google is just releasing this last December. You have 2 million window contexts and you can freely use it, which is great, right? So yeah, but it changes on a weekly basis almost. Like DeepSeek version 3 was just released really recently, and it's constantly new players are joining. So as you know, I organized Devoxx Belgium. The beauty of organizing a technology event is that you get a view of what's being suggested by all these interesting speakers. And so last year we had about 900 proposals, and this is a tag cloud of all the keywords that were used in these 900 proposals. And what you see, there are 3 keywords here which were not present 2 years ago. Generative AI, large language models, but very more importantly, that was not on the plan at all, is LangChain4j, the one on the right. I'm looking at Spring AI, but I don't think Spring AI is there, or it might be, but I mean, Spring AI was a bit behind, but they're doing similar things. So if you're a Java, everybody's a Java developer here, or just out of interest? Yeah, so like 60%. If you're doing Java, then there's basically 2 options if you want to work on an abstraction layer, which is LangChain4j and Spring AI. Those are really the 2 nice options. And Mario Fusco is now recently involved also in LangChain4j, so you can talk to him. But that's very interesting. Now, what's more interesting, and that's the story I want to talk about, is that previous Devoxx, so not last October, but the year before, I had Anton doing an opening keynote, and he works for JetBrains. And they announced their AI assistant. And I actually took a screenshot because it's streamed live with subtitles. And I asked him, hey, will you support local large language models? And any idea if that's going to be open sourced, etc. And it was twice, no, I don't think so. I was like, damn, because I really wanted to have these local models as well. And so I waited, it was October 2023, November, December, January, nothing. I was like, okay, you know what? I'll develop it myself. So what I did, I went on a mission where I wanted to develop my own coding assistant, but for IntelliJ. I'm an IntelliJ user. IntelliJ users, I would say 80%. I already did that this morning, but yeah. And so I said, like, I've never developed a plugin before, never, so it was the first time, but I had already these models helping me. So these are the superpowers that we are getting with these models. I mean, you get more confidence because, like, you're not on your own. You have these models that can actually help you do this stuff. So that's what I did. I went like, okay, let's try this out. Rainy weekends. We have a lot of rainy weekends in Belgium. So, you might as well do a bit of programming. And I developed an open source project called Devoxx Genie. The reason why it's Genie, because the Genie is out of the bottle. This is like, large language models are out of the bottle. We're not getting the Genie back into the bottle. Yeah. So it's a new world. And the beauty of the plugin that I developed, well, few things. 1, fully open source. 2, it's free. There's no business model behind it or whatever. It's a hobby project. I want to experiment and do research and development of what's possible. So that's my way of channeling that energy. And it's fully written in Java using LangChain4j. Right? So you can look at it. The beauty is that it runs on all the JetBrains products. So I still do a lot of Python. Nevertheless, like especially for agentic programming, I'm working on a proof of concept in Python. Well, I can use PyCharm and still use that plugin. Let me show you that. And it's getting a bit of traction. I mean, that's fun to see. We're getting close to 9,000 downloads, which is great. And I've been told informally that JetBrains really loves the plugin as well, even if they have their commercial tool, which is you have to pay for their commercial tool. And the beauty of this one is that it supports all the models, local ones, remote ones. You can mix it and match it, etc. And I'll demo it after this slide, which is here. So let me start up IntelliJ. And so you can just go to the marketplace. Can you see this okay? Settings, plugins. Here, you just type in Devoxx, and you get the plugin, and you can just install it. Right? What's cool about it, so once you've installed it, you have this icon here, Devoxx Genie. You can click on it, and you can actually select the different local models and cloud models that you want to use. So you basically enable them. I've got all the local ones running, and the 3 ones that I'm using currently is OpenAI, Anthropic, and Gemini. And if you just click on the key, it will take you to the website where you can create your OpenAI key, or sorry, your API key. You often do have to provide a credit card to get that key. But once you've done that, it is available in the chat. What's really interesting, I used to use an open source product called Code to Prompt. It was a Python project, Code to Prompt. And what that one did is that it actually took your full code, your full project, and created one prompt, which had a tree of your project and all the source code. And so I've actually mimicked that using this feature here, scan and copy project. So what you can do here is you can say which directories should be excluded, which files should be included. Do you want to use git ignore as well to dictate what files should be included when you copy your project to the prompt, right? So, and then the files, etc. So that's cool, because what I can do now, like for example, let me go to Devoxx. This is like meta programming. I will use Devoxx Genie to do Devoxx Genie. Hold on, let's do that. That's okay. So here, I can calculate the tokens of this project. So there it says, okay, this project is 140,000 tokens, 222 files, and it's going to cost you nothing because I've selected Google Gemini experimental version 12.06. And it even shows you the number of tokens here, right? So what I can do, I can actually add the project. So here you can see it. I've added 140,000 tokens. It actually has copied my whole project. Let me open a file. Do it here. Whatever. There it is. So I just copied my clipboard. And what you see is this is what, when I do add project, it creates like a file structure of how the project is constructed, so it knows the relationships. And then once it's done the file structure, it will start showing the files themselves. So when I do add project, and now I say, hey, what are the top 10 refactorings for this project, right? And typos don't matter. It understands what I'm doing, right? It knows the context, so you can have typos. It now has sent 140,000 tokens to Google for free. It's using electricity. And it will take about 2 minutes to get a response back, right? You can also enable streaming, but what I often do is that I have like more sophisticated requests, and I will just go for a coffee or go to the toilet, come back, and I'll have an answer, right? So this might take 2 minutes, but it's basically talking to Google. Once I get a response back, it will allow me to actually then start switching. So now I've got a response, which is great. So you can see this here. Let me make it a bit bigger. Voila. So it's suggesting certain things. It took 32 seconds, 168,000 tokens, didn't cost me anything. And now I can go, for example, to Anthropic and say like, select Sonnet and say like, hey, review what Google is suggesting and improve it. Voila. And so remember the chat memory? So it keeps the previous questions and answers and the full project in the prompt. It's now sending it to Anthropic. And so what I'm doing, I'm just playing with multiple assistants. And by just having them review each other, you often come to some very nice results once you've stopped the conversation. Cool, eh?
Yeah. Do you risk to amplify or reduce, let's say, hallucination in this case? I mean,
So the question is, do you reduce hallucination or do you amplify? I'm now doing very naive sentences, right? You have to really put a bit of effort in what you're asking. The more specific you are, I mean, it should not be one sentence. It can really be multiple sentences. And so the more specific you are, the better results you will get, right? Just for the sake of demos, I'm just doing simple ones, but don't do one-liners. Be really precise. The preciser you are, the better results you're going to get. Right? So here
I have another question.
Go on.
So you explained before about the context of each model. So in this case, you are mixing Sonnet. Sonnet has a more lighter context.
Yes.
What about if you have a larger project? You can keep switching between providers?
So the project is 140K. I know Sonnet has a limit of 200, so I was able to use both of them, right? But if your project is 1 million tokens, then Sonnet won't be able to help. Then I've built another feature, which is an experimental one, which is using RAG. So you can actually start Docker. It will download ChromeDB, and it will vectorize your project using embeddings, and then you can do semantic search to create smart window contexts. Instead of doing brute force, you do smart window context. But let's be very clear, the smart window context is always better made by the developer itself. So that's why I also have this feature where you just basically do plus, and you can add files here, service or whatever, and it will find the files for you, and you create your window context manually. If you are the owner of the project, or involved in the project, this is much better, right? So the brute force is more like with a project that I don't know. I just put the full project, but I have no idea where the beginning and the end is. But if it's your project, you know, for example, I need this controller, this service, this repository, or whatever, just include those, and then come up with some suggestions of refactoring, or write a unit test for me, things like that. Right?
Thank you for that.
You're welcome. And this is superpowers. I mean, I do this for PyCharm, I do this for PHP, like I do WordPress plugins for the Devoxx website. I have an idea for a WordPress plugin. I can build this in 2 hours, seriously. I build plugins in 2 hours just by using this mechanism. So I'm like being much more productive. Okay, I am already a senior developer, that helps, right? If you're a junior developer, you have to watch out, because like Sonnet might say, you want to do this application? Well, you should first write your own caching mechanism. You're like, what? Caching mechanism? I'm using Spring Boot. There's an @cacheable. I don't have to build my own caching mechanism. But if you're a junior, you go like, I need to build a caching, and then off they go, right? So it does help being a senior developer, but if you're a junior, just use the different models and let them review each other. And they might actually say, no, use @cacheable instead of building your own, right? Cool, let's move on. So make sure you install it this evening, play with it, seriously. If you want to know a bit more, there was Gunther Rotzart. He gave tools in action at Devoxx Belgium. That's the link to the talk. It's on the YouTube channel of Devoxx, and he goes in a bit more detail how to use the plugin. He's also one of the contributors who joined the project. And so I did this demo at Devoxx Belgium in October, and somebody, of course, tried it. And this is Dominic, and he said, like, just trying Devoxx Genie on my M3 Max. Just pulled Llama 3.2, 132,000 tokens, works reasonably fast, and something with F. This thing is amazing, right? So he added his full project and said, create me a README file, and it just did an amazing job, right? So, like, I know people at Red Hat, they're just using Devoxx Genie only to create good Java doc comments. And in the plugin, there's even a Git diff, so you can actually do a diff comparison and just apply the different Java docs using the Git diff tool from JetBrains. So the next part, the second part, is really about what's Java here, what's the position of Java. Because what I've shown you up to now is Java in the IDE, because JetBrains is Java. The plugin is Java. but the inference is still Python. And Python isn't the fastest programming language or executable language out there. Java is much, much faster. So wouldn't it be great if we could do inference also in Java, right? What it seems is that we are starting to see the small puzzles being positioned to make this happen. And the important ones there, well, we already have version 9 or the 9th edition of the Panama Vector API. The Vector API allows you to do matrix multiplications very fast. And you know, most likely, if you do inference, it's all about matrix multiplications. That's where the bottleneck is. So Vector API helps a lot on that. The problem where we are, and then we have the foreign functions and memory, which is also very important because we can swap portions of memory very quickly from one location to the other. But what I'm really waiting on is GPU support. We want to have those matrix multiplications on GPUs. Currently in the US, in the UK, we have Tornado VM. They have some approaches to this, but we're really waiting for Babylon. I mean, Babylon is this abstract layer where we'll be able to actually have matrix multiplications executed on a GPU, but in an abstract, agnostic way. So if you're running on CUDA or you're running on ARM or on Mac, it will know where to transcompile it or whatever, how they do it, because it's very sophisticated. But that's what we're really waiting for. And so there are already 2 projects that I actually invited at Devoxx Belgium last year, which is JLlama and Llama 3.java. Those are 2 fully written Java projects doing inference using the Java language. One is by Jake Luciani. You can look at GitHub. He open sourced the project. The QR code is the link to his talk from Devoxx Belgium. And his code is beautiful. It's poetry. If you look at his, I mean, I get a bit demotivated because when I look at his code, I go like, okay, I can't develop like him, so I will not try to build my own vector database because he did an amazing job. I can't copy that. So I'll just join and use his tool instead. And it's very, very straightforward. You just clone the project and you just say JLlama, REST API, and then the model you want to use. And the second part, or the last part, is the auto-download. So if that model is not yet on your local system, it will download that model for you. And it's using the OpenAI REST API. It's compliant with the OpenAI REST API. So that means you can just, with LangChain4j, just use the OpenAI client and just connect to it. So that's pretty neat. Let me show you that. So I think I've got that here. JLlama. So you just here it is. So I just started. So it's a Spring Boot app for the REST controller. And then here I can have my custom open API, and I can say, like, tell me a joke. Oh, joke. And you see it's communicating with Spring Boot, and it tells me a joke. It's not impressive, but what is the beauty here is that I can debug, because it's all Java, I can debug and understand, I should stand here, how the large language model works. So I can go through all these matrix multiplication and try to understand it, and just go really to just the tensors. So, I mean, as a boy, you always wanted to open the toys and see what's inside. Well, this is your opportunity now, because with Python, we couldn't. Now we can. We can go immediately to the details. So and it was pretty fast. I mean, and that's not even native. That's just pure Java. So that's already good. Cool. So that's one. So make sure you have a look at that because it's very, very promising. The other one I'm very excited about is the Llama 3.java project. This is developed something. Oh, this is developed by Alfonso Pettersson. He's from Zurich. And they did a talk together with Alina at Devoxx Belgium where they demonstrated this. It was actually the first time that he did a presentation, so he was really nervous, but he did an amazing job. The cool thing about Alfonso is that he works for the Graal VM team. So he's like he has the right connections because they're doing some bleeding fast JVM optimizations and native compilation, etc. And what was really fun for me, I spoke at Vox Day CERN earlier this week, So I invited him to be my co-presenter, and so we did a talk together about actually this session, but he did the Llama 3 Java part. And so what's Llama 3 Java? The cool thing about this is that it's Java inference, but it's implemented in one single Java file, just one file. And it's 2,545 lines, including comments. So that's a full LLM inference in less than 2,500 lines of code. That's pretty neat, right? And he did this in the evening, in the rainy weekends. So it's a single file, no dependencies. He supports the GPT-generated unified format. He uses the Llama 3 tokenizer based on the one from the previous Tesla AI expert, Caparci. I always have a problem pronouncing his name. It supports float 16, binary float 16s, and quantized version of Q8 and Q4, which is pretty neat. He, of course, uses the Java Vector API, but what's really important is that he's able to create a native image. So he can create a native executable on Linux and have it run faster than Llama CPP. Faster than Llama CPP, right? That's great. I mean, that's what we need, right? So I can replace my old Llama, which is now, they migrated to Rust currently, but we will have Java-enabled LLM inference, which will be faster than anything out there and fully written in Java. Job done, right? I mean, and that's not even using GPU yet. That's pretty exciting stuff. Unfortunately, it's not yet ready for Mac, so I can't demo the Mac version just yet. But they've announced, well, they've told me it's going to happen this year for sure. So I'm hoping for Devoxx Belgium that they will be able to demonstrate that fully native inference. And they're even doing ahead of time model preloading. He did a demo a couple of days ago at CERN, and he was printing out how many milliseconds it took to start the model. It showed 0 milliseconds because it was in nanoseconds. So, I mean, that's really great. That's the power of Java, right? I mean, you can really go very, very fast. So that's cool. And since he did the keynote, he did the talk at Devoxx Belgium, he added also float and binary float 16s. Now, if you know your data types, Java doesn't support 16, so he's basically using 32 floats and just using half of that. But that's important for certain weights that he needs to support. There were some donations as well for the first token appearance, which is now running in parallel. And the Graal compiler improvements in Inference is 20% faster than previous demo in October. So they're really making some very interesting enhancements. And so they are using JDK 24 Early Access Edition build 15+, and this is how you can install it. So let me show you that. I still have 13 minutes now, okay. So this is the one file. And as you can see, if I scroll down, 2,545. And for me, it's too I don't understand this code, right? For me, that's too complicated, to be honest. But what I can do, I can go to Devoxx Genie, add the project, like this Java file, it's just one file, and then let's go to Anthropic, Sonnet, and then I think there's like the forward method, which is really interesting. Here, this one, where it does the multiplications here. So I can say like, hey, explain me the forward method in this file. Right? And so that's the beauty. For me, that's Chinese. Well, it's not Chinese, but I don't fully understand it. But with an AI assistant, it could really explain me how this works, etc. And that's like, that's really cool. Otherwise, I would be just sitting at home and have no idea how to approach that. So there it goes. It's just explaining me the forward method and blah, 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 and so on. Well, you get the idea, right? Yeah. So unfortunately, what he did is that it's just an inference engine. He did not provide a REST interface. So I remembered, actually, I was flying to one conference, and during the flight, I built a Spring Boot using a local Ollama model to support me, right? Because I'm not smart enough to do that on my own. And I built actually a Spring Boot wrapper around his Java files so I can actually talk to it using a REST interface. So that's pretty neat. Let me show you that, if that's how that works. So I think I've got it running here. Run. I do need JDK 23, but this is just using JDK. It's not using native, right? So it's not as fast as the native one. But now I've got it here, Llama 3 Java server. And so I can talk to it again using, let me close this one, using the custom API, and I can say stupid things like, tell me a joke. Let's see how it reacts. And there it is. Oh, that's a big joke. Okay. It's including the full previous conversation, so it might take a bit longer. Let me start a new one. Otherwise, it's going to take too long. Something had to go wrong, right? Come on, stop. Let's see if I can start it again. If not, just believe me, it does work. Okay. Tell me a joke. Nope. Tell me a joke. No, lost it. Anyway, I think I've did something wrong there. But what he told me is that he's going to provide it as a service, like a Maven package, where you can just wrap it yourself, which makes sense. What I would like to do, because it's like, I would like to include the native versions of Llama 3, included it in the plugin, so Windows, Linux, Mac, and then use that one as auto-completion, because if it's 0 milliseconds, it's going to be really fast to actually do the auto-completion for me. So there's definitely some interesting use cases there. Cool. I've still got 9 minutes. Another thing I would like to quickly highlight is LLM sharding. So if you're running on-premise or you have at home a few computers laying around, like I have, there's this cool presentation from Devoxx Belgium from Mohamed Bayoumi. He has an open source project called EXO in Python, but it's focused specifically for Apple Silicon. And Apple has actually a library called MLX, which allows you to actually do inference on the Apple Silicon. And so what you do is that you clone the project, you run it on your different Apple machines. So this is a real copy of my setup at home. So I have like a Mac Mini, a MacBook Pro, and a Mac Studio. And it combines actually the power of these different machines as one, basically, LLM provider. Now, this will not run faster, it will actually run slower, but what it does allow you to do is that it allows you to run a 400 billion model on your 3 machines, which normally doesn't fit on one machine. So it's really like, I think I mentioned that this morning as well, it's like DB database sharding as well, but now doing that on different layers. Now, this is in Python, but Jake actually even implemented this also in Java. And he even went a step further. He didn't even shard it on layers. He even shards it on intention heads, whatever that means. But he's using multiple strategies to even shard the LLM models. So have a look if you want to play with that, or if you have like I've already got a few people in Belgium who said, we don't want to use cloud providers, but we would like to have like Llama 3.3, 400 billion parameter one in the office, then this could be a potential approach. So what are the other LLM opportunities? Well, like I already said, the large language models running locally. GPU support, I have not even seen the results of that, and that's definitely going to happen. I mean, I'm just going to invite the Tornado VM guys and say, like, hey, if you can show GPU support for LLMs, you can talk at the keynote about that, and then all of a sudden they're interested, right? So it's like this carrot you can put in front of their eyes, and they will actually do that then, and hopefully open source it as well. So that's always cool. They've already done this for version 2 of Llama 2.java, but not the 3 version. That's the link to that paper. The Llama 3 one does not yet even support key value caching, so there's still opportunities there as well to make it faster. And what's not even involved at all, because that means it's a rewrite of the inference, is, for example, support for bitnets. So bitnets, they just use 3 values, -1, 0, 1, and it actually is able to still create sensitive or valuable responses if it's a really big large language model. But the result is they only need 3 values, so the size is really small. As a result, you can actually run it on-premise on your computer. Another one which I'm interested in is also layer skipping. So a large language model might have 40 layers. So it needs to go through 40 layers. And so this is a technique from Meta where they're saying, no, let's skip 1 or 2 layers and see what it comes up with. And it seems it's still actually giving good value, even if it's skipping layers. So it's like if you cut a small piece of your brain out and you're still able to speak, then, okay, maybe that part we didn't need it for speaking, right? So that's a bit like that type of stuff. And the other one, which is really interesting, again from Meta, is byte latent transformers. So I think if you went to the previous talk, we have tokenizers, so we talk about tokens, and tokens are like 2, 3 characters, right? So you might have one long word, and that word might be constructed out of 2 tokens, right? The problem is that this is a running joke. If you ask ChatGPT how many R's are there in strawberry, because it tokenizes strawberry in 2 tokens, it doesn't know about the berry, which has 2 R's. Right? With byte latent transformers, it uses a byte. So it knows about every letter. And as a result, you have much more interesting conversations because it knows about every word, all the letters in there, and it's not tokenized. So that's also something you should keep. Well, it's an interesting investigation of what could be done there. So 5 minutes left. What's next? Well, I've already mentioned that. I mean, for me, what's next? Well, this one is on top of my list for Christmas or my birthday. I want that one because I want to just see how, if I have a petaflop, and rightly somebody mentioned it, yeah, but it's a floating point 4. So yes, it's not as powerful as a 16 or a 32-bit float, but it looks promising, right? And that's only $3,000. So that's cool. I've mentioned the AI agents. I probably scared everybody with Mark Zuckerberg's video. I do apologize for that. But I could have done also the CEO of Salesforce, who has the same message, and Google has the same message. So these messages are being distributed in the ether. And the AI agents, they all have very similar patterns. So they have a goal. You need to define a goal for that agent. Then you have certain planners and steps. And like a goal could be one LLM, which is like really good in planning. And then another LLM could be very good at creating steps for that goal. So that's where you start mixing and matching different LLMs based on their added value. And then you need memory and context to know where they are. Maybe use external resources like web search or just your project. It's optional, but it's good to have human evaluation. So you can say, okay, apply, oh no, reject, redo it, apply, and so on. But some can just go full automatic as well, and then there will be surprises. And then you use the tools. Yeah? So the tools is basically it could be calling a method in Java, but it could also be calling a Unix command, etc. And that's where the magic happens, because it knows about its tool set, and it will start using it based on the context or the goal it needs to achieve. Right? And then you can even deploy it to a sandbox. This could be local on a Docker instance, or I'm now playing with model.com. I wasn't aware of that 2 months ago, but it's an AI cloud provider which allows you to really deploy your code very rapidly, and you can use that as a cloud sandbox. And then it will reserve to error handling. If there are errors, something doesn't compile, it goes back into the loop, and you do autocorrection. And that's basically, these are really the mechanics of real agentic agents. Make sure you look at this, because this is where the fun is. But it's also, like I said, it's a quantum superposition state. It's both fun and scary at the same time. I've already mentioned that. I'll skip through that. For the people who didn't see the keynote, this is a bit the ecosystem of AI agents. But I would like to include, you can see it from me. I'm not faking this. I really am excited about the possibilities. As a Java developer, I've been doing this for many, many years. It's really great that we have Java now as well for inference. I can really debug until the weights are being used. Please try it as well at home or at your work. And don't be afraid. Embrace it. And I would say thank you for your attention. We still got 1.5 minutes. If you have a question, I probably can do 2 questions. Any questions? Yeah.
When are you planning to develop the agentic version of the extension you're working on?
Yeah. So I've got a proof of concept working, but it's in Python because I started first in Python. This is my last conference talk for the Q1 of this year. So the next 3 months, I'll be basically adding agentic in Devoxx Genie for IntelliJ. That's my plan. I'm hoping to be able to do that. But I actually submitted a talk for Devoxx UK and Devoxx France, which is in April and May. So that's like my deadline. So I'm hoping to have a version there. But it's like I said, it's a hobby project. It's experimenting and doing a bit of research, etc.
Well, let's hope we still have rainy days, because
this
is amazing, man.
Yeah.
This is crazy.
I appreciate that. Thank you. I appreciate it. Thank you.
Any other questions?
Any other questions? I'm still here for about 2 hours. I think I have to leave then. But thank you again, and have fun.